Okay, so in this video I'm going to continue the transportation problem, which already have discussed in different parts. So just go to visit the different part, then you will be confident over the different types of questions which already have discussed related to transportation problem. In these videos I am going to solve this problem by applying UV method, and UV method already have solved in the previous videos to get the optimal solution. So I already have applied the UV method over the Vogel's approximation method questions to get the initial basic feasible solution. So I already have solved these questions by applying the Vogel's approximation method to get the initial basic feasible solution. Once I've got the initial basic feasible solution, then I moved for UV method to apply this particular method to get the optimal solution. So now I'm going to get the same questions because questions is same. It will be easy for you to compare because the result will be same. Optimal result cannot be changed. In initial basic feasible solution, result might be changed, but in optimal result cannot be changed. Optimal means that the answer must be unique. Either you are going to apply UV method or a stepping stone method, either over the Vogel's approximation or northwest corner cell or least cost cell method. So optimal result must always be unique. So now I am going to apply the UV method over least cost cell method. So this problem, first I will apply the least cost cell method, least cost cell method, LCM, that is the abbreviated, to get the initial basic feasible solution, Okay, so now first least cost cell method I will move fast because this problem already have solved in previous videos. So in part 3, I think in part 3 already have solved, part 2 or part 3, just to check. So here I am going to move fast because main aim to go to solve this problem by applying UV method. So first we need to concentrate over the UV method. That is important, how to apply the UV method to solve these types of problem. So now initial basic feasible solution for this one. So least cost cell method means we need to check which cell is going to give you the least cost. So this 5 is the least out all over these cost. So we will move here, this 30 will move here. So this is 0, now this is 10. So we can say this demand already have got fulfilled, so there is no more demand, so none of this supplies is required. Now next least cell, so here we can say this 6 is the next least, so this 20 will move to this cell. So this 20 have got finished, there is no more demand. Here 15 is left. Next least value, out of all this value, this 8 is the next least value. So out of this 45 and 15, 15 is the least, so 15 will move here, 15 have got finished. Now this will become 30. So here next list, this 9 is next list. So for 30 and 50, 30 will move here, this is 0. So now 30 have got finished. Now here I have got 20. So out of these two, and this 13 is the least one, so 20 will move here, 20 have got finished, 10 is left, and 10 is 10, these two are equal, it will move here. So this method already have discussed in previous video, just for the use, because now going to use this least cost cell method because this is the initial basic feasible solution. So if you are going to solve this one, 15 into 8, 20 into 6, these are the allocated cell, 9 into 30 into 9 plus 20 into 13 plus 10 into 16 plus 30 into 5. If you are going to take this or this allocated cell, this result will be 1080. So if you calculate, result will come 1080. Okay, just to calculate, then you will see this is the result. Now I am going to apply the UV method, and I already introduced, this is also called MODI method, modified distribution method. So what is UV method? First just need to copy this table. So very easy procedure. Nothing, just you need to remember some basic steps only to proceed, and according to these steps, if you are going to proceed, you will get the result. So first you need to copy 8, 6, 10, 9, 12, 13, 7, 14, 9, 16, 5. So just have copied here 35, 50, 40, 45, 20, 30, 30. Before going to solve UV method, because we are going to move to get the optimal solution. First we need to check either all the numbers of allocated cells are enough or not. If this condition is going to fail, it means we cannot move to get the optimal solution. There is further steps to first to fulfill the criteria, then only can move to get the optimal solution. So here this I'm not going to talk about that criteria, just I'm going to talk, because for that criteria I will make the separate video. For generally we call as a degeneracy. So wherever these degeneracy exist, so we move for to first to fulfill the criteria, then only we can go for the optimal solution. So here we are not going for this particular condition, just going for the checking m plus n minus 1. This is number of allocated cell. So just for the checking number of allocated cell. So number of allocated cell, how many allocated cell? There are 6 numbers of allocated cell. M is nothing, M is a number of column, number of rows, N is a number of column. So number of rows 1, 2, 3, 3 rows, a number of column 1, 2, 3, 4, 4 column minus 1. So 4 plus 3, 7 minus 1, 6. 6 is equal to 6. This condition I have got fulfilled. Now it means now we can move to get the optimal solution. Okay, so very easy. First to check. If this condition is going to fail, then there is another step. First to move to that particular step, then only can move for the optimal solution. But once this condition is going to satisfy, then directly we can move for the optimal solution procedure. So what is the UV method? UV method is going to say to put U1, U2, U3. UV method means in the rows you need to write U1, U2, U3, and in the column you need to write V1, V2, V3, V4, whatever numbers of column you need to write like this. And initially first we need to set U1 as a 0. This is fixed one. So which cell is going to already have given allocated cell? So these cells are allocated cell. 20, 30, 20, 10 and 30. These cells are allocated cell. So there is a formula Cij is equal to Ui plus Vj to find the U and V value. So very simple. Cij is the cost, per unit cost. Already I have given in each cell. So 8 is the per unit cost. So just we need to move to add these two value. These two value means here U values U1 have given 0, and we need to find V, and Cij already have given 8. So it means if you are going to add these two value, you will get Cij. So 0, and if you are going to put here 8, 0 plus 8, that is 8. So U and V value only can be calculated for the allocated cell only. Wherever we are going to see the allocated cell, there only we can move to apply this formula Cij is equal to Ui plus Vj. Now, so 0 plus 8, 8. 0 plus 6, we can say this 6. Now same, here this is the 9. 8 already is here. So 8 plus 1, 8 plus 1, 9. No, this is the allocated cell. So here 13. So 13, 1 already I have given here. So 12. 12 plus 1, 13. So 13 is here. Now this is the allocated cell. This is the 16, and 12 already I have given. 12 plus 4, 16. Now this cell is left. This is the 5. 4 plus 1, 5. I think you have got very simple. Just you need to go 0 plus 8. Check 8. 0 plus 6, 6. 1 plus 8, 9. 1 plus 12, 13. 4 plus 12, 16. 4 plus 1, 5. Just like this you can you may proceed to get the values of U and V. Once you have got the values of U and V, then there is a step. So before going to see the steps, just you need to write what is the initial basic feasible solution. Have got here 1080. 1080 have got by applying the least cost cell method. So now I am going to move for the next step. Next step is what? Next step already I have seen in previous video. Cij minus Ui plus Vj. We need to check this one. Either this one is greater than or equal to 0 means positive. If it is positive, it means this result itself is an optimal solution. If all these unallocated cell is going to give you the positive result, it means the initial basic feasible solution whatever we have got by applying this method, if then itself will be the optimal solution. But in between, if any cell is going to fail this positive condition, it means we need to move for the third step. So what third steps is going to say, we'll see after these steps. Okay, so now just check. For checking, we will move for this particular cell and we'll see what this cell is going to say. Cij. Cij is what? Because this formula is for unallocated cell. We need to check for all unallocated cell. check for all unallocated cell. So first unallocated cell is this one. Okay, so for this unallocated cell, Cij is what? Cij is 10. So just you write 10 minus, what is the ui? 0 plus Vj is 12. It means 10 minus 12, result is minus 2, result negative. It means this condition is going to fail. It means there is a chance to go for the reduction of transportation charges, means there is a chance to minimize the cost of transportation. So now this cell is going to ensure, means there is a chance to go for the to minimize the cost of transportation. Now which cell have ensured? This cells already have ensured, so now we can move for further for reduction. Okay, now so how to move, that is the question. So very simple, just we need to form a loop, already have discussed like this, just form a loop with allocated cells. So now we have formed the loop with allocated cell. So this is the loop, because wherever you are going to start, this is the plus, then minus, then plus, then minus. Why we are going to write this one? So already have discussed, because this positive is going to affect these quantities. So to manage this quantity, we need to reduce the some numbers, so then only you can manage. If you are going to here reduce, it means you need to add to manage these supplies, numbers of products. So this is the procedure only. We are going to give the plus minus alternate with all allocated cell only. Okay, now so here it is going to ensure, means if you are going to write this value as a theta, if you are going to consider this value as a theta, so this negative is going to say you to put minus theta. This positive is going to ensure you to put plus theta. This negative is going to say you to put minus theta. So once we have considered this theta is going to ensure which cell is going to leave their positions, because which allocated cell is going to become unallocated cell and which unallocated cell will become allocated cell. So this cell already have got selected for the allocation, so this cell will become allocated cell. So we need to check here in the negative value. So 15 minus theta and 20 minus theta. For the negative theta we need to find, so which theta is the less, because least positive value means theta. If we will put the theta is equal to 15, then this result will give you zeros and this will become 5. If you are going to consider theta 20, means this will become negative, and negative is not allowed. So here, so maximum values of theta is 15. So if you are going to put the 15, this result will become, because here is a 15 minus 15. So theta is going to put here values, theta is a 15. Now theta 15 means 20 minus 15, this value will be 5. Next 30 plus 15, this one will be 45, and 15 minus 15, it will become 0. So this cell have this cell is called unallocated, and this cell have got allocation. So now here if you are going to check, then definitely result will get reduced. The cost is going to be, transportation cost is going to minimize. So now you can check for here 20 into 6 plus 15 into 10 plus 45 into 9 plus 5 into 13 plus 10 into 16 plus 30 into 5. If you solve this one, you will get 1050. What will be the result? 1050. Just you solve this one, then you will get total 1050. Now initially it was 1080. So 1080 have got reduced to 1050. It means 30 rupees of difference, you can say, here in the transportation cost. So if you are going to allocate this particular position, then this cost is going to get reduced. But this is not a final one. We cannot say this itself is an optimal solution. Why we cannot ensure? Because we need to move to check is there some unallocated cell is going to give you some more means reduction. So we will move for the same step for the further we will move the same steps to check is there some other cell is going to give you some more reduction. So just now going to apply the concept. This is 35. Now we'll see here, this is 1050 for this. So now again we need to find u and v. So how to find u and v? Very simple, just you need to put u1 u2 U3, V1, V2, V3, V4. Again we need to go to find, because this condition is for allocated cell, and initially allocated cell was this one. Now allocated cell have got changed, so U and V value will get changed. Now U1, especially for this one, we can say this is the 0. Then we will go for the, again checking. Now here we can see U0. So this one is a 6, 0 plus 6, this one will be 6, this is 10, 0 plus 10, we can say. Now V3 value will be 10. So here this one already 10 and this one 13. So 10 plus 3, we can say 13. No, 10 plus 3, it will be 13. And am I right? Here 6 plus 0, 6, 10 plus 0, 10, 10 plus 3, 13. Okay, so here for this allocated cell 3, 3 plus 6, 9. For this allocated cell, this one is a 12. So 10, 10 plus 6, 16. For this allocated cell, this one is 6, this one is 5. So here minus 1. I think this is at 6 plus 3, 9. Okay, 0 plus 6, 6, 10. Okay, so it's a correct. 6 plus 6 minus 1, 5, 6 plus 10, 16. Okay, is right. So now we can go for the next concept. What is the next? Then we can check either some unallocated cell. So this is the next unallocated cell. Either this cell is going to give you positive or negative. So very simple. Just put the values in here. Cij is 9 and Ui, for this Ui is 0 and Vj is minus 1. So 10 minus minus plus 1 is going to give you positive value. So wherever you are going to get positive, so no need to go for further, because our aim to reduce the cost. No means if the cost is going to minimize, then only we can say the cost of transportation is going to be reduced. Okay, so now here for this cell Cij. What is the Cij? What is Cij for this cell? For this unallocated cell, Cij 12. This is the cost. Ui 3 plus Vj 6. So 12 minus 9, positive. So here also going to give positive. So just read positive. Okay, check for this cell. 7 and 7 minus Ui 3 plus Vj minus 1, plus minus minus 7 minus 2, positive. So here also going to get the positive. So here write positive. Okay, now check here 14 and 6 plus 6, 12. 14 minus 12, 2. It's also positive. Positive. Now here 9, 6 plus 6, 12. 9 minus 12, negative. Here I've got negative. Here I've got negative. It means there is a chance this cost may get reduced. Means cost is going to be reduced. So transportation cost means in this steps, once we will move for this particular steps, then here we can ensure the transportation cost is going to be reduced from 1050, because in that steps the cost was 1050. In next step the cost will get reduced from 1050 to some other cost. So now we'll check what is the cost is going to get here. So what is the procedure? Procedure is very simple. Once we have got this negative, it means we need to put here dot. We need to mark dot here. So just mark as a dot here and move with its allocated cell, respective allocated cell. So we can move like this, here to here, here to here, here to here, here to here. We can say these are the cell we can move. So this cell will become allocated and some cell will become unallocated, plus minus plus minus. So now very simple. Now we can say here this is this cells have got selected. So here we can put theta. So here 10 minus, this will become 10 minus theta. This will become 15 plus theta. This will become 20 minus theta. So now we can say these cells have got selected. Now we can move for the calculation. So 20 minus theta, 10 minus theta. So which one is going to give you the less value? Theta value is 10. If you are going to put this 10 here, then this will be 10. 10 minus 10 is going to give you 0. 15 plus 10, this is the 25, and 20 minus 10, this value will be 10. So now new allocated cell, already I've got this 10, 5. Now here also you can go for the checking, because once you already have checked this condition is going to satisfied, it means this condition is not going to fail, m plus n minus 1 condition, because allocated cell, because just we are going to change, we are going to replace unallocated to allocated. This means whatever cell have got already allocated, that will move to unallocated, and that cell will become unallocated, and other cell will be allocated. So this is the procedure. No need to check for all the times for m plus n minus 1 condition. So here, whatever the result? No. See here. Again go for the checking. What allocated cell? 10 into 6 plus 25 into 10 plus 45 into 9 plus 5 into 13 plus 10 into 9 plus 30 into 5. These are the allocated cells. If you are going to calculate 10, 60, 250 plus 405 plus 65 plus 90 plus 150. If you are going to add this one, what the result will come? 0, 0, 5, 5, 10, 0, 1, 6, 15, 21 is just to add 60, 250, 405, 65, 90, 150. What is the result? 1, 6, 15, 15, 25, 26, 32, 33, 1020. So now the result is 1020. So initially the result was, by initial basic feasible solution, 1080. In the second steps the result was 1050. In these steps result have got reduced to 1020. So now we can say at this step, because we already have visited all the allocated cell to unallocated cell, and we already checked where it is going to give you the optimal. And if you go back to C, I already have solved the same questions by applying here the Vogel's approximation method and UV method. So result was same, 1020. That is the optimal solution. But that is not a criteria, means you need to go to check by applying the Vogel's approximation. That is not in criteria, just for the confirmation, because through the Vogel's approximation we have got the same result, and once we applied the UV method, so we got the same result. So Vogel's approximation method itself was an optimal solution for this particular questions, not all the times. So here we can say 1020 is the optimal result. So optimal solution for this question is 1020. So I hope you understood the concept, and it is very simple, very easy. So just practice over some numbers of questions, then you will be more confident. Okay, all the best. Thank you very much.